geometry. We're going to do section 3 of chapter 9, and it's chock full of good stuff. So get ready. I'm going to actually look at the book for once and try to make sure that I get everything in there, okay? All right, so this section's on arcs and chords. Remember that here's the center of your circle. And if we draw from one edge of the circle to the other, that is called a chord. If you draw a chord, you make a minor arc and you make a major arc, right? So the first thing they start with is theorem 9.2. And it says that in the same circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So let's just draw another chord. So what it's saying is this arc is congruent to this arc only if, oh, sorry, I should have done that. So those two are congruent only if these two are congruent. Okay, that's theorem 9.2. And you could do kind of a quick little proof of this. Just maybe like draw a triangle here and a triangle here. And I think we can kind of reason through this really quickly. I'm not going to write down the real formal proof here, but so they want you to prove that, like if they tell you that these two are equal, the two arcs, we're going to prove that these two chords are equal, okay? So, so if that arc is the same as that arc, then we know that these two angles are equal, right? What did we learned that last section? Is that 9.1? I kind of forgot. Give me a second. Pause. Yes, it's theorem 9.1. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So, if these two arcs are congruent, then we know these two angles are congruent. Furthermore, we know that all of these are the same, right? Do you see why? Because they're all radii. They're all going from the edge of the circle to the center, edge of the circle to the center. So we know all those are the same. So by the side angle side theorem, we know that these two are equal to each other because they're corresponding. Okay, so quick little proof. That's theorem 9.2. Let us continue on. Get rid of some of this messiness. Draw another circle. And this is theorem 9.3. It says that if a diameter of a circle is perpendicular to a chord, then it bisects the chord and its arc. So, diameter of a circle, and we've got a chord, and if this is perpendicular, then it bisects this into two equal sections. What else does it say there? It says it bisects the chord and its arc. So it also bisects this into two equal sections, okay? That's theorem 9.3. 9.4 says the perpendicular bisector of a chord is the diameter of the circle. So it's kind of it's the converse, all right? So if I make really messy. So if I make any chord, boom, and I just figure out the perpendicular bisector of that, then I know that this is going to be the diameter of that circle. It's going to go right through the center. Okay? That is 9.4. Okay, they're coming fast and furious here. And I think we have one last one. It's 9.5. 9.5 says that you can tell two chords are congruent that chord and that chord. We know these two chords are congruent if and only if they're equidistant from the center. So in other words, if I draw a perpendicular bisector here and a perpendicular bisector there, this distance is going to be the same as that distance if these two are the same. Okay? So if you have two congruent chords, then these two lengths are going to be congruent also. To top things off, as if you haven't learned enough today, you've learned more than the price of admission. But I'm going to show you a quick construction. And I have searched the house, and I must have left it at school. I cannot find my compass, so I'm going to do kind of a fakey construction, okay? So let's just do, if you have 3 points, any 3 points, we'll call it A, B, and C. And if I want to draw a circle that the edge of the circle contains those 3 points, here's how you do it. You draw this line and you figure out the perpendicular bisector of this. So remember how you do that? You reach out with your compass and you draw a little arc, then you reach out the same distance and you draw a little arc, and then you reach out the same distance up here, draw an arc, reach out the same distance here, draw an arc, and then you draw a line through those points. Do you remember that? I can't remember what chapter we did that in. It was a while ago. Do the same thing here. Draw a line, reach out, boom, reach out the same distance, boom, reach out the same distance, boom, reach out the same distance, boom, and then you draw the perpendicular bisector of those. So this is going to be a perpendicular bisector, this is going to be. Think about the theorem we just did. We know that these perpendicular, or not that we just did, but sorry, I think it's 9.3, right? Oh no, sorry, it's 9.4. We know that these two are now going to be the diameters of a circle. And you know that the diameter of a circle goes through the center. So the place where these connect has to be the center. And so if I take my compass and I just reach out the same distance, like whatever this distance is to C, and I draw it, I'm going to have a hard time doing this just like this. It is going to contain all 3 points. Okay? So you would get a very nice circle that contains all 3 points. Okay, there's your little bonus construction. And I think that is it for section 3. All right.